Alright, so for this question, it asks you to find the directional derivative by using the gradient. So the equation for directional derivative involving with the gradient is as follow. So you have the gradient multiply the unit vector. So to find a unit vector, first we're going to take q minus p. You would have 4 minus 0, 1 minus 0. You should get 4, 1. And now you can divide it by the magnitude of this vector, q minus p, or the u vector. You would have, not the u vector, just the magnitude. So you would have 4 squared plus 1 squared, you get root 17. So your unit vector will be 4, 1 divided by root 17. So you get 4 over root 17, 1 over root 17. Now you have the u vector. Now let's find the gradient. So to find the gradient, you find the partial derivative respect to x, and then find the partial derivative respect to y. So you will get the gradient will be partial respect to x. So you would get e to the 9y cosine of x. Now, respect to y, you treat x as a constant. So you get 9 e to 9y sine of x. Now you can plug in 0, 0 because it asks you to find the derivative, the directional derivative at point P. So if your gradient at 0, 0, you will get 9 times 0, so you get 9 times 0 cosine of 0, and 9 times 0 up here, and then sine of 0. So you would get 1, 0, because this whole thing gonna be 0, and this is gonna be 2, 1, and this is 1. Alright, so now your gradient is 1, 0. So now you just multiply, find the dot product between the gradient and the u vector. So you will have 1 multiplied for 4 over root 17, 0 times plus 0 times 4 over root 17. And your answer, or your directional derivative, should be 4 over root 17, or 4 root 17 over 17.